All right. Hopefully everyone can hear me. So good morning and welcome to the preservation team's Sprint 14 demo. As a reminder, we've been working on an application that will allow us to inventory and audit objects in SDR, or the Stanford Digital Repository. Checksum validation, this sprint's focus, is a process within the overall inventory and audit service that allows us to guard against bit rot and maintain confidence in the integrity and identity of files in an SDR object. This is achieved by comparing checksums for those files cataloged in an object's metadata with checksums that we calculate in real time to compare for sameness. So let's begin with a look at our steps to production document that we featured in previous demos. The hearts on the checklist mean that we have deployed what we believe to be a complete approach to checksum validation to our staging server. And we're testing the code out by running it on read-only production data sources. To go into a little bit more detail, let's look at the current process logs. As you can see here, we have information about timestamps on the left that indicate when an object has gone through validation. We have the identifier of the object here, which is a Druid. We have its location on disk, here services disk 10. And we have a brief message saying whether checksums match or not. We started running checksum validation on storage root 10 yesterday afternoon at about 3 p.m. After an hour, we had validated a little over 700 objects of about 50,000 on that route. And after 3.5 hours, the figure had risen to 2,100 objects. That's approximately 10 objects validated per minute. At that rate, validation on that storage route will take 89 hours or just over 3.5 days total. If we could run checksum validation on all of our storage routes in parallel, by our calculations, we'd be able to finish a complete run in 7 to 10 days, which meets our performance requirements. And in fact, our catalog application is open to parallelization. One possible approach we've discussed is to spin up multiple instances of the catalog application and configure each to point at and process its own storage route. Overall, this type of traversal takes longer than the types of checks we've previously demoed. And that's because calculating checksums is a relatively expensive operation. So now I'd like to turn our attention to some facts and figures that measure the team's productivity over the past week. As you can see, we've merged 5 pull requests, we've closed 7 and spawned 4 new issues. 3 of us have push commits to master. 170 files have changed, with 347 additions and 111 deletions. And you can see that there's been a little bit of conversation around these 14 open issues. We have 4 developers that are currently assigned to the team, and our 4th developer has been hard at work on the preservation robots repository related to our next milestone, which is to hook up the robots to the catalog so that as we ingest objects into SDR, the robots will be able to trigger the processes necessary to begin inventorying and auditing those new objects. And stay tuned to future demos for more on that milestone. The team is looking ahead to tying up any loose ends we might find surfaced by our test run of checksum validation, after which we'll cut a new release of the catalog, we'll deploy to production, and do a full run of the process there. We're also looking ahead to the ingest robot hookup, as mentioned. We met this week to begin developing a high-level picture of what the milestone after that will look like, which is the archive and replication component. That will allow us to ship true archival copies of SDR objects to the cloud and free us from non-archival but currently necessary tape backups. The team is also looking ahead to a design review presentation to the entire infrastructure team of the preservation project that will hopefully help us to develop stronger design practices across DLSS as a whole. So I'd like to end by checking in on the checksum validation process live. As you can see here, I checked in on the number of objects that were validated around 10:20 a.m., just before the start of the demo. And here we are checking in at the end of the demo. So in the time, let's see, in the last, let's say 20 minutes, we processed about 188 objects. So that's audit in action. So thanks very much for your attention, and we'll see you at the Sprint 15 demo.